Welcome back sa ating YouTube channel. And today, pag-uusapan naman natin ang electric potential. The learning objectives of this session is first, to relate the electric potential with work, potential energy, and electric field, followed by to evaluate the potential at any point in a region containing point charges. Lastly, to define the notion of an equipotential surface. So we have here electric potential energy. By definition, electric potential energy, denoted by the capital letter U, is the energy needed to move a charge against an electric field. It is zero when all charges are infinitely far apart. Class, ang ibig sabihin dito, ang energy na kailangan natin para makapagpagalaw ng isang charge against an electric field ay ang electric potential energy. It is expressed in units of joules or the capital letter J. Electric potential energy can be mathematically described as the delta U, or the change in potential energy, is equal to the final potential energy denoted by the U sub F minus the initial potential energy denoted by the U sub I, also equal to the negative work done by R electric field. So in here we have an illustration wherein we have two charges subjected under electric field. We have a positive point charge and a negative point charge. Ang expected reaction natin dito is that the positive point charge will be attracted to the negative plate and ang ating negative point charge will be attracted sa ating positively charged plate. So the energy comes with that motion is the electric potential energy. Now we have scenario 2 kung saan ang ating negatively charged is supposed to be going to the right, and with this motion to the right, ang ating expected route ay medyo slope downward. So magkakaroon tayo ng pababang motion dahil as our negatively charged goes to the right and is under the electric field, it will be subjected to an attraction force making it move downwards. Also, ang atin namang positive charge, kapag ka nag-move din siya to the right, will also be subjected to an attraction force under the electric field, making it move upwards. So, meron tayong final route na pataas. So, we have the following analysis na nabanggit natin kanina, that when a charge is moved from one point to another in an electric field, it requires energy. And the work done can also be an external force. Meaning, pwede tayo maglagay dito ng external force para mapagalaw ang ating negative charge o ang ating positive charge sa ating desired direction. On another point of view, we can say that the electric field is doing a negative amount of work para mapagalaw yung particle. So, we can move the charge by applying an external force, or the electric field is applying a negative amount of work, a negative amount of energy, so that the movement of charge will occur. So we can say that the change in potential energy is equal to the negative work done by the electric field. Moving on, we have electric potential energy. The work necessary to move a charge from an initial point to the final point is independent of the path chosen. Sa madaling salita, regardless daw kung ano ang dadaanan ng ating charge, pareho pa din ang work. In here, we have a positive Q charge on point A and gusto natin siyang mapupunta sa point B. So the easiest path to make the charge, the positive charge, go from point A to point B is to draw a direct line. Okay, so this is the shortest path to move a positive point charge. Now, we also have another path na pwede nating sabihin that will also result a movement of the positive point charge from point A to point B. So we have an example of path 2. So sa path 2, makikita natin na medyo mas mahaba yung kanyang movement compared sa ating path 1 na diretso lang. So sabi dito that the work done at path 1 and path 2 are essentially the same. So pareho lang daw. So later in this session, we will verify and discuss kung tunay nga ba na pareho lang ang work sa dalawang ruta na ito. So we have electric potential. By definition, electric potential denoted by the capital letter V is the amount of work needed to move a charge from a reference point to a specific point without producing an acceleration. So, medyo similar siya ng definition sa ating electric potential energy, but the main difference is that it is the minimum energy required to move a charge without producing an acceleration. Now, bakit natin ina-avoid itong acceleration nito? Because comes acceleration when we have a presence of an acceleration, we will also produce kinetic energy sa ating test charge. So, we have to avoid that. Electric potential is defined as the potential energy per unit charge of a test particle. More precisely, it is the energy per unit charge for a small test charge that does not disturb significantly the field and the charge distribution. Electric potential is scalar and is expressed in joules per coulomb or the capital J per capital C or volt denoted by the capital letter V. Electric potential can be mathematically described as V is equal to U over Q or also equal to K multiplied by Q over R, where V is the electric potential, U is the potential energy, and Q is the test electric charge. K is the Coulomb constant and R is the distance between charges. Now, we have electric potential difference. Electric potential difference denoted by the delta V, also known as voltage between 2 points, namely A and B, is defined to be the change in potential energy of a charge Q moved from A to B divided by the charge. It is the change in potential energy class. Okay? So, meron ditong dapat pagbabago. So, dapat nagbago ang value or ang magnitude ng ating potential energy. Voltage or the electric potential difference is the energy per unit charge. So, we have here joules per coulomb pa din. Or, pwede na nating sabihin, mas simple, in volts or the capital letter V. We have the following formula for the electric potential difference. We have the delta V is equal to VB minus VA, also equal to the delta U. The delta U over the Q, the test charge, and is also equal pa din sa ating work applied over Q. So we have the delta V, the potential difference, and U is the potential energy of charge moved from 2 points. And Q is the charge. So solving sa ating work applied, we will now multiply Q by both sides. We will have work applied is equal to Q multiplied by the delta V or the potential difference. We have here equipotential surfaces. By definition, equipotential surfaces are regions in space where the electric potential is constant value. So, constant value ang ating electric potential, and with those constant value, we can form equipotential regions. So, we have two equipotential regions in three-dimensional or in 3 dimensions. We call it equipotential surfaces. And if two-dimensional plane naman ang ating pinag-uusapan, we call it equipotential lines. Now, equipotential surfaces can be described as the change in potential or the delta V is equal to 0. It takes no work to move a charged particle between 2 points at the same potential. So, kanina sinabi natin to that when we have two same potential values, that the movement of particles will require no work. So to prove this, we will use the formula of the work applied to verify kung talaga nga bang walang work kapag kapareho ng potential. So we have the formula of the work applied is equal to the product of Q and delta V. So expounding the delta V or the potential difference, we can say that the Q multiplied by the VA or the potential at the point A minus VB, the potential at point B will result to 0. Kapag ka nga naman pareho ang value ng VA and VB and sinubtract natin silang dalawa, the resulting work will be 0. We have work in equipotential surfaces. Okay, we have this illustration. We can see that we have two surfaces. We have S1, the topmost surface, and S2, S3, and lastly, we have S4. Meron din tayong apat na potential. So we have V1 for S1, V2, V3, and V4 sa respective surfaces natin. So we have here an analysis. The work on equipotential surfaces can be calculated using work is equal to negative Q multiplied by the potential difference. So very evident that we have four roots na obserbahan. We have root number 1, root 2, root 3, and root 4. So ito ang movement ng ating charges sa ating planes. For root 1, we can say that ang ating initial point ay surface 1 and ang kanyang final point ay surface 1. With this, dahil nasa isang surface lang ang ating 2 points, the potential difference is equal to 0. Bakit? Kasi nga, sabi sa ating definition that when we have an equipotential surface, the potential difference between them is 0. Dahil ang potential sa buong surface na ito ay constant. And with that, using the same formula ng work, when our potential difference for root number 1 is equal to 0, the resulting work will be 0 as well. Now, we have root 2. Tingnan naman natin ang movement ng charges sa ating root number 2. So in here, we have a starting point sa ating S3 and bumutas ngayon siya pababa and after niyang bumaba, nag-penetrate naman ulit ngayon siya pataas. Ang ending point natin or the final destination is also S3. And since katulad ng root number 1, ang ating final destination ay nasa surface 3 pa din. So from ang ating initial point ay nasa surface 3 and our final point is also on surface 3. Regardless of the path, regardless sa ruta na dinaanan niya, pareho pa din ang ating potential. V3 pa din yan on all points sa ating surface number 3. And with that, ang ating potential difference ay 0 and therefore, ang ating resulting work will also be 0. So looking naman sa ating root number 3, we have an initial point of surface 1. So nasa surface 1 ang ating initial point or starting point. And nag-penetrate siya sa ating surface 1, landing on surface number 2, wherein ito na ang ating final destination. With this, hindi na nasa isang plane ng ating dalawang points. Nasa magkaibang plane na sila and magkaiba na rin ang kanilang potential, meaning there is potential difference. Now, the resulting work will be the negative Q multiplied by the potential at surface 2 minus the potential at surface 1. So, we have a resulting work. Dahil wala na tayo sa equipotential surface, nagkaroon na ng changes in potential. We have potential difference. And lastly, we have root number 4 na ang ating starting point ay si surface number 1. Nag-penetrate ngayon siya sa surface number 1 and crossing pa din sa ating surface number 2. With that, dumaan naman siya paakyat and ang kanyang final destination ay surface number 2. With this, dahil magkaiba na ulit ang ating surfaces, magkaiba na ulit ang ating potential, we also have a resulting work. Ang ating work number 4 will also be negative Q multiplied by the difference of V2 and V1. So mapapansin natin class na pareho lang naman ang value ng work 4 and ng ating work 3. Bakit? Dahil pareho lang ang kanilang starting point and initial point. Regardless sa dinaanan nila, regardless kung gaano kaikli or kahaba ang kanilang dinaanan na ruta, pareho pa din ang work nila. Dahil pareho ng starting and pareho ng ending point. Next, we have here equipotential lines. What can we evaluate or observe when we are talking about equipotential lines? Equipotential lines is perpendicular to the electric field. In our first illustration, we have a uniform electric field, uniform in direction, and uniform in magnitude dahil pare-pareho sila ng length. So we have an uniform electric field to the right and is horizontally positioned. To make the equipotential line perpendicular to the horizontally positioned electric field lines, dapat ang position niya ay vertical. So vertically placed to, and we can observe that there is a 90-degree separation between the two parameters. Now, we have a positive point charge. And in this point charge, nag-emanate siya ng electric field lines radiating outward. Since ang ating electric field lines ay radiating outward, hanapin ulit natin ang perpendicular component to make or to draw the equipotential line. So looking at this first vertically placed arrow or the electric field lines, we can say that the equipotential line, which is perpendicular, is horizontally positioned. So in this case, perpendicular pa rin siya, medyo slanted, and making a circular path sa ating radiating electric field lines. Kaya mapapansin natin na meron tayong circular broken lines dyan. So this represents the equipotential lines. Lastly, when we have two charges and these two polar opposite charges undergoes attraction. So na-discuss natin sa ating last session that they will have this electric field lines or the behavior of the electric field lines. The following equipotential lines will be observed as well. Nagiging dense din siya sa part na ito and sa part na ito. With those, let us proceed sa ating sample problem. So for our sample problems, sample problem number 1 states that you have a 12 volts motorcycle battery that can move a 5 kilocoulomb of charge and a 12 volts car battery that can move 60 coulomb of charge. How much energy does each deliver? So listing the following given parameters, we have the QMC or the charge of the motorcycle. We have the voltage of the motorcycle. We also have the charge and the voltage of the car battery. So for the required, we are required to compute the energy delivered by the motorcycle battery and the energy delivered by the car battery. Solving this problem, we have the following formula. So we have here the change in the potential energy of the motorcycle battery equal to the charge multiplied by the voltage. Substituting the values, we have the 5 times 10 raised to 3 coulomb multiplied by 12 volts will result in a 60 kilojoule energy. So para naman sa ating car battery, we still have the same formula. Substituting the value of the 60 times 10 raised to 3 coulomb multiplied by the same 12 voltage, we have a 720 kilojoules energy. With this, ano ang ating observation? sa nakuha nating mga sagot? What can we conclude? So, although pareho ng voltahe ang baterya ng ating motorcycle and ang ating battery sa ating kotse, magkaiba pa rin ang kanilang energy na kayang ibigay. Okay? So, that does not mean that kapag ka mataas na yung voltage mo, mataas na agad yung energy mo. Okay? So, voltage and energy are related but they are not the same. So, magkaiba ito. Okay, moving on. We have the last problem. We have here a sample problem number 2. A charged particle of 1.4 millicoulomb moves a distance of 0.4 meter along an equipotential surface of 10 volts. Calculate the work done by the field during this motion. So, listing the given parameters ulit, we have a charge, we have the potential sa ating surface of 10 volts, and we also have the distance. So, ang hinahanap natin dito, class, is the work applied or the work done by the field. Dito pa lang, alam na agad natin na 0 dahil we have the keyword of the equipotential surface. Alam natin that the work done in an equipotential surface will always be 0 because the potential difference is 0. Calculating the potential difference, dahil parehong 10 volts ang ating potential at A and ang ating potential at B, we will have a 0 potential difference that will result in a 0 work done by the field. With this comes the end of our session, and kung hindi ka pa nakasubscribe, mag-subscribe ka na para naman updated ka kapag ka nag-upload ulit ako ng video next week.